matrix number 01 DEP22F1012.
My name is Muhammad Hafiz bin Faizi and my matrix number is 01DEP22F1035.
Assalamualaikum and hi. My name is Muhammad Syahmi bin Muhammad Babul Isham and my matrix number is 01DEP22F1016.
My name is Ian Azril bin Razmi and my registration number is 01DEP22F1041.
Okay, so my responsibilities is slide maker. Next, what is differentiation? Differentiation is used widely in solving problems, especially in engineering, medical, commerce, agriculture, and many other fields. When you find the rate of change of a quantity with respect to another quantity, you are actually doing differentiation. Another name for differentiation is the derivate of the function. If a person is running up a hill, his vertical height will change the respect to his horizontal height. This rate of change of vertical height with respect to horizontal height is called its gradient.
Application of differentiation in real life. Differentiation equation application in real life are used to calculate the movement or flow of electricity, motion of an object to and fro like a pendulum. To explain thermodynamics concept, also in medical terms, they are used to check the course of disease in graphical representation. It also can be used to calculate the profit and loss in business using graphs, to check the temperature variation, to determine the speed or distance covered such as miles per hour, kilometer per hour, and more. Derivatives are used to derive many equations in physics.
So next, question C. First Roman, second Roman, third Roman. Y equal to 5x power of 3 plus 2x power of 2 minus 7x minus 2. First Roman, find dy dx. So the dy dx equal to 15x power of 2 plus 4x minus 7. So power of 3 times with 5, we get the 15. Power of 3 minus 1, we got power of 2. Same concept for 4x and minus 7. Power of 2 times 2, we get 4. So power of 2 minus 1, we got x. So next, second Roman, find the coordinates of any stationary points on the curve. At stationary point, dy dx equal to 0. So 15x power of 2 plus 4x minus 7 equal to 0. So in bracket, x minus 0.563, open the new bracket, x plus 0.83 equals to 0. So stationary point for x1 equals to 0.563, x2 equals to negative 0.83. Substitute x1 equal to 0.563 into y1. So y1 equals to 5 in bracket 0.563 power of 3 plus 2 in bracket 0.563 power of 2 minus 7 in bracket 0.563 minus 2. So the answer for yx is negative 4.415. So next, substitute x2 equals to negative 0.83 into y2. So y2 equals to 5 in bracket negative 0.83 power of 3 plus 2 in bracket negative 0.83 power of 2 negative 7 in bracket negative 0.83 minus 2. So the answer for y2 is 2.33. So the stationary points equals to the first in bracket 0.563 comma negative 4.415 and in bracket negative 0.83 and 2.33. So third Roman, how many stationary points does the graph have? So the graph have 2 stationary points.
For question 4, to get y-intercept, x must equal to 0. So we put 0 in the first equation. Y equal 5 multiply 0 power of 3 plus 2 multiply 0 power of 2 minus 7 multiply 0 minus 2. So y we get minus 2. So for y-intercept is 0, minus 2. For the next one, to get x-intercept, y must equal to 0. To get x, we must use calculator. So first, we choose EQN and press 3 for degree. And we put the equation from the question. For x1 we get 1.14 and x2 we get minus 1.26 and x3 we get minus 0.28. For the next question, the question asks to determine the nature of stationary point. So to get that, we must dy dx for the second time from the equation. So we get 30x plus 4. After that, we put 0.56 from stationary point in x1 in the equation, and we get 20.9 bigger than 0. Then that's the minimum point. And for second one, we use the same step, and the answer we get minus 20.9 smaller than 0, and that's the maximum point. And the last question, we put all the answer that we got from the question 2 and 4 to the graph, and that's it.
So I will do question D. Okay. First question is dy dx. To find dy dx is by 3 multiplied by negative 5 and you will get negative 15, and 3 minus 1 you get x squared, and then 2 multiplied by negative 2 and you got negative 4, and 2 minus 1 you get 1, so x plus 1 multiplied by 7 equals to 7. Second question. Find the coordinate of any stationary point on the curve. Okay. Negative 15 squared minus 4x plus 7 equals to 0. Then use calculator to find the value, and x1 you will get negative 0.83 and x2 equals to 0.56. To find how many stationary point in the graph is by substitute x into y. Okay, first x1 equals to negative 0.83 into y. So put x1 into the question and you will get negative 2.33. Then you need to substitute x2 equals to 0.56 into y. Replace x with 0.356 into the question and you will get the answer of 4.41. So the total of stationary point is 2.
Bismillahirrahmanirrahim. My name is Ian Nazril and I'm going to show you how to do question D, 4, 5 and 6. Number 4, y intercepts x0. So you have just to replace x with 0 and you got the answer of 2. That means the coordinate is 0 and 2. Y intercept y0. So in this question I got 3 coordinates. The first one is 1.138, the second one negative 0.28, and the third one is negative 1.26. Number 5, determine the nature of any stationary point you found in part 2. Justify your answer. So in part 2, we can get the answer negative 0.83 and 0.56. So that is the first differentiation. So you have to do the second degree differentiation to get the negative 30x minus 4. So you gotta replace x with negative 0.83 and you get the answer of 20.9 as a minimum point. So negative 0.83 is a minimum point. Next one, at the point x equal to 0.56. So you first of all you have to put 0.56 on the x, replace it, and you get the answer negative 20.8. That means x equal to 0.56 is a maximum point. Number 6, sketch the graph of the curve. This is the graph. So as you guys can see, 0.56 and 4.41 is a maximum point, and negative 0.83 and negative 2.33 as a minimum point. So as you can see also, 2 is a y-intercept. So this is the graph answer. Thank you.
The last one is summary. Differentiation is a method of finding the derivative of a function. Differentiation is a process in maths where we find the instantaneous rate of change in function based on one of its variable. The most common example in the rate change of displacement with respect to time called velocity. So that's all from us. Thank you so much. Have a nice day.